So hi, we are from Group Stress Kit from 3CS2303B. So we are present about properties of relation. So this is our members. So for background study, we choose question 2, which is focused on the properties of relation that consists of reflexive, symmetry, and transitive. The objective is to develop a C++ program that check whether a given relation satisfies these properties and generates the corresponding closure. So to talk about problem statement. So many students struggle to identify whether a relation is reflexive, symmetric, or transitive, often making error when checking multiple properties manually. So to address this, a program is purposed that allow user to input set and relation automatically verify these properties, and also it generate the corresponding closure, helping reduce mistakes, save time, and also improve understanding. So next is flowchart program. So for this flowchart, it's illustrate a program that reads a set of element and a relation from a file, store the order pairs, and also display the original relation. It then check whether the relation is reflexive, symmetric, and transitive by verify condition like the presence of XX for reflexivity, BA for symmetry, and AC for transitivity. If any property is missing, the program apply the appropriate closure by adding the required pair and print the update relation. So if all properties are already satisfied, no closure is performed and the program terminates.
So next, I will explain the interface of the system. So first of all, we read the input by reading in a file, which is, this is our file example for file relation. So here, this is represented as our element, and then this is all of our relation. So as you can see from the coding, first of all, we declare the elements which is maximum number is 50 in array, and then we declare the relation A and then relation B with the number maximum is 200. And I also do the declare for element count and relation count. So first of all, this is a first function, which is relation exists. So this function actually to check whether the relation is already exists in the file. So for next function, this is a function for relation. So actually this function to check the adding a new relation, which it will count the new relation for A, and then it will count the new relation for B. So for the next function, this is a function to check whether the relation is reflexive. So it will return false if the relation does not meet the condition. And then we also have a function for the symmetry. So this function actually to check whether the relation is symmetric. So it will return false if the relation does not meet the condition. And then this is a function for transitive. So transitive, it will show the relation is transitive if the relation is meet the condition, which is if A and B is exist, and then B and C is exist, then A and C must exist. This is a function for reflexive closure. So reflexive closure function actually to add a new relation if the relation does not exist. And then this is the function for symmetric closure. It also do the same function, which is adding a new relation if the relation does not symmetry. So this is a function for transitive closure. Also, we will adding a new relation if the existing relation is not transitive. So it means that it show the transitive in a transitive closure. So for function for print relation, actually it will print all the existing element and also the adding element. So it will display all the element that we already adding and also exist in the relation.
Next, I will explain the coding for our window function. We have arranged our coding so that all the coding for the window function are put below the coding of our relation question. In this window function, we use switch case, which consists of 3 cases. The first case is WM destroy. The second case is WM command. This second case is for the coding of our relation topic. This coding line is to get input from file and followed by an error message. The third case is WM pane. This is for us to adjust the color, the border, and the font of our window function. In this coding block, we can see that this is the background color of our window welcome screen. Next is the border color of our welcome screen. This is the border, and this is the shape, which is rectangle. The next coding line is for us to set the background to transparent so that the text can be seen and read clearly. We have 3 hash font, which is because we have 3 phases in our welcome screen. Group project CSC 510, properties of relation, and prepared by group 7. Hash font 1, this is the coding line to determine the font, which is Comic Sans MS. This is the color of our text, which is orange. This is the text, followed by H12 and H13. Next is H button pen, which is the button for get started. This is the color of our border, which is green, and this is the shape, which is round rectangle. This is the font area for the button, and this is the text get started. This is the main function. This is an error message if the window screen failed. Next is the name of our window. Welcome to the relation project. This is the error message, and that's the end of our window function.
So next, for demonstration of our coding. So here we set our file with file relation.txt. So after we save, we test by using our coding. So we run the coding. The first thing that came up from the window screen is our window page. Okay, we click the get started. So after that, it will automatically decide whether the relation is reflexive, symmetric, or transitive.
Now I will talk about the analysis of the result. This project aims to develop a program that reads a set of elements and their relation and then determine whether the relation is reflexive, symmetric, and transitive. To evaluate the correctness of the program, 4 test cases were analyzed. Next. In example 1, the relation satisfies all the 3 properties. Every element has a set pair, so it is reflexive. Its ordered pair has inverse, making it symmetric, and all required transitive pairs are present. Therefore, no additional pairs were added during closure generation. Next. In example 2, the relation is not reflexive, not symmetric, and not transitive. Some self pairs are missing, inverse pairs successive 5 do not exist, and required transitive pairs like 1, 3 are absent. After applying closure, all the missing pairs were successfully added. Next. For example 3, the relation again found all the 3 properties due to the missing self pair, inverse pair, and transitive pair. The closure process correctly generate all the required relation until the relation become complete. Next. In example 4, the relation is symmetric but not reflexive and not transitive. Reflexive and transitive closure were applied, where symmetric closure was not needed. Next. Overall, the result show that the program correctly identifies relation properties and generate accurate result, proving the reliability of the algorithm. However, one limitation is that the system only reports the first missing ordered pair during validation. Future improvement could display all the missing pair to improve user understanding.
To conclude, relations are important in discrete structures because it describes how the elements relate to one another. While doing this project, our group members were able to gain a better understanding of the properties of relations and the steps to solve the problems. As can be seen from the previous slides, we have divided the tasks equally and presented our group project with a complete discussion of the background study, problem statement, analysis of the result, algorithm of the system, and a well-written program with a complete output. We managed to implement the concepts by writing a program that allows users to determine the properties of a relation, compute its closure, and observe how the properties change with different inputs. Through this group project, we learned how mathematical concepts can be turned into simple yet accurate instructions in a program. We also learned why it is better to use computational tools to simplify complex problems and how to demonstrate the concepts in a practical way through the program. Overall, we achieved our project's goal and hope that this group project can be a small contribution that will help enhance our understanding of discrete structures in the future.